Hello everyone, this is Maths Fundamentals. We are continuing with Earth geometry, and in this lesson we are going to pay attention to how to calculate for distance along small circles. Remember, when we are talking about small circles, we are referring to distance along latitudes except the equator, because it is the only latitude which is a great circle. When calculating distance along small circles, all you need is to have a bit of some knowledge to do with circumference or perimeter of a circle, ratio and proportion, and trigonometric ratios. Just to refresh our minds, formula for a circumference is C is equal to 2 pi r, where a complete circle has 360 degrees. Arc length, and in this case, the arc length of that distance along the small circle, the latitude, is equal to theta degrees over 360 times 2 pi r cos alpha degrees, which simplifies to theta degrees over 180 pi r cos alpha degrees. And radius of the Earth is equal to r, which is 6371.0088 kilometers. So where we see r, small r, we are going to replace it with the capital R, which is the radius of the Earth. Now, here is something that we have to know. That alpha degree is the latitude or the small circle where those points are. Well, the theta degrees being the angle difference between the 2 points or location, those points that are along that latitude or that small circle. So here is an example of an arc YZ. Remember, this arc represents the distance between 2 points which are along a small circle, which is a latitude. In this diagram, we have alpha degrees, which is 82 degrees according to the formula. Remember, alpha degrees represents the angle or the latitude where those points are. Theta degrees is 77 minus 31, which is equal to 46 degrees. And r, it will be capital R, which is 6371.008 kilometers, which is the Earth's radius. Now let's continue with something interesting. Why is cos alpha used when finding distance along small circles? Wow, this is so wonderful. Let us see why. The reason is simple. The reason is the radius of a small circle is usually unmentioned or highlighted, and it varies according to the degree of that particular small circle or latitude. Therefore, each time when you are calculating for distance along small circle, the radius has to be figured out always. I have a cross section here of a small circle which is 60 degrees north with reference to the equator, which is at 0 degrees. Now, how do we find that small r, which is the radius of the Earth? Let me just highlight with my pen what we are talking about here. How do we find this distance here for small r? So, when you've drawn this latitude 60 degrees north and the equator, I will draw a line from the center of the equator and to the surface of that particular latitude. So this line here is the one we are talking about. It will come here. Once I draw that line, this line becomes the radius. As you can see, from the equator to any point on the surface is the radius of the Earth, which we know as capital R. This angle here and this angle, they are equal, because this angle, it is the angle that is being made when you turn going to this latitude, which is 60 degrees. Therefore, alpha here is 60 degrees, the angle which is being made between that latitude and the equator, which is 60 degrees. So these are alternate angles. So this angle, if it's 60 degrees, which is alpha degrees, this one also is alpha degrees. Therefore, we have to find this small r with reference to the angle alpha. And as you can see, r is the adjacent side if we use alpha as the angle, and capital R is the hypotenuse. Therefore, when we have the adjacent and the hypotenuse, we are going to use the cosine as a trigonometric ratio here. So it will be cos alpha is equal to the small r, which is the adjacent, over the capital R, which is the hypotenuse. Now we want the small r, we'll make it subject to the formula. So it will be, we'll multiply by the reciprocal, the inverse of r. So it will be r is equal to capital R cos alpha r. So that is why this cos alpha is used in that formula. Where is it coming from? It is coming from when we try to find r in reference with the angle and the radius of the earth. Let us see now how the formula is constructed. And r is equal to capital R cos alpha degrees. And then we have 360 degrees, which is equal to 2 pi r, which is circumference of a circle. Remember also small circles, they are circles. And then we have now theta degrees, which is equal to yz. Theta degrees, the angle which is made between these 2 points, yz, okay? So using ratio and proportion, we can arrange the formula like this. 360 degrees is equal to 2 pi r over theta degrees is equal to yz. Because these are proportional, they're direct proportional. The angle is direct proportional to the distance of that arc or the circle. Okay? Finally, we'll have something like this. When you multiply by the inverse of yz, some they say cross multiply, but it's the inverse or multiplicative inverse or reciprocal. Yeah. Basically, that's what happens there. We'll have 360 yz, and then again we multiply by the reciprocal of 360 on both sides. We are going to remain with something like this, where yz is equal to 2 theta pi r over 360. Now remember, this r, we've already found a solution to it. We have to substitute. What is r? This r is the radius of a small circle. How is it found? It will be r is equal to capital R cos alpha. We found it just in this same lesson. So finally, the answer will be like this, or the formula will be constructed like this, where yz is equal to 2 theta pi r cos alpha over 360. And it will simplify to that. Theta pi r cos alpha over 180. Basically, that is how that formula I gave you at the beginning is constructed. So, do not memorize formulas, but know how they are derived. Okay? Great. Now let us find the solution to this question. Let's find the length yz, which is a small circle. Remember, theta is the angle difference between those 2 points. So 77 minus 31, we had found is 46, times r, which is the radius of the earth, cos alpha, it is 82 degrees, the angle which is made between the equator and that latitude, which is same as the same latitude, which is 82, times pi over 180. Finally, your answer will be like this, where it will be 711.8667799 kilometers. And you are done. So in the next lesson, we are going to look at how to calculate for the shortest distance.